My relatives assume I engineer autonomous supply chains. I actually spend my Tuesdays begging a compliance board to approve a 2-megapixel camera. The camera simply identifies misaligned labels on plastic tubing. Factories lose massive capital on manual inspection because regulators demand determinism. Machine learning operates on probability. If a model is 99.8% confident, the compliance officer rejects it, and the factory floor defaults back to human labor. We solve this by isolating the inference variable. A 48-hour protocol allows us to build a locked edgeai node that meets the strict requirements of a hardware audit. Standardizing the setup allows the factory to automate the visual grind and replace the increasing defect rates caused by human fatigue. To satisfy an auditor, you must abandon cloud connectivity. Removing external links eliminates variable software outputs. We deploy a ruggedized, air-gapped edge compute appliance directly on the physical inspection line. Intel catalogs several of these systems for industrial use. When the cable locks into the port, the physical boundary is established. Hardware alone is insufficient. The software inside the box must be prevented from adapting or learning. We freeze the neural network weights entirely. This process ensures the model remains static throughout the life of the deployment. We define strict input arrays and force the inference script to execute in under 200 milliseconds. Locking these weights turns the algorithm into a static mathematical filter inside a steel box. Confining the software to this localized hardware creates the input A equals output B consistency that regulators demand. We test this configuration with a 48-hour shadow run on a single inspection line. The edge compute node runs in parallel with the human operators. As each frosted syringe slides into the focal plane, the camera captures the image and processes it locally. During this period, the system logs every output array to a local CSV file. This log records binary results, pass or fail. It avoids any mention of confidence percentages. These records prove the software footprint is physically limited and consistent. A flawless 48-hour log provides the empirical evidence required to bypass regulatory skepticism. Following the test, we draft a 150-word installation qualification brief. This brief includes the hardware serial number, the frozen status of the weights, and the 200-millisecond execution limit. We attach the deterministic CSV log to this IQ brief as the primary verification. We submit this validation pack to the regulatory body to certify the hardware architecture once. All subsequent line deployments are treated as exact physical and digital copies of the approved framework. Certifying a rigid physical framework once allows the factory to skip the complex validation of new models for every line. The final step is presenting the CSV data to the Chief Compliance Officer to obtain a binary approval decision. Automating the repetitive inspection loop returns operator focus to complex failure analysis and root cause problem solving. If you face a compliance wall for a basic inspection loop, reply to this video. I will send you the 150-word template for the initial IQ draft. Using rigid constraints to solve these bottlenecks rescues capital and allows frontline operators to move from staring at conveyor belts to investigating actual system failures.